What if the biggest rocket ever built is just one flight away from being caught in midair by a giant pair of mechanical arms? That's not science fiction anymore, and Elon Musk just hinted that it might happen sooner than any of us expected. Before we dive into this wild week in spaceflight, do me a quick favor. Smash that like button, hit subscribe, and share this video with someone who still thinks rockets are supposed to crash after launch. Your support keeps this channel flying, literally. Now let's get into it, because there is a lot happening. And Starship is only part of the story. Blue Origin is quietly rebuilding a launch pad that was blown apart. Rocket Lab is planting flags in new corners of the world. A brand new rocket in the UK is finally standing tall. India just made history with its first private orbital launch. And somewhere in China, a rocket got hit by lightning and just kept flying. So buckle up, because this week in spaceflight is packed. Let's start with Blue Origin, because their story this week is honestly fascinating. Back in late May, the company was running a static fire test on their New Glenn rocket. Everything looked normal until it wasn't. Something went wrong, and the rocket exploded. The fireball erased the vehicle from existence and left the launch site looking like a war zone. Thankfully, nobody was hurt. The safety zones did their job. But Launch Complex 36, the pad that was supposed to send New Glenn to space, was basically destroyed. Now here's where things get interesting. Instead of just rebuilding what they had, Blue Origin decided to rethink the whole thing. Their CEO, Dave Limp, announced a 5-step plan to get back to flying, and part of that plan involves changing how the pad actually works. They're calling it a new concept of operations. In simple terms, they're not going to use a transporter erector anymore. That's the giant machine that usually rolls a rocket to the pad and stands it up. Instead, they'll use cranes to lift New Glenn onto the pad and then connect its fuel and power lines directly to the launch tower. It's a bold move. It's also a slow one, because it means redesigning hardware they've already built. This week, we got a look at just how deep the damage really went. Dave Limp shared a video of a massive crane pulling something out of the flame trench. That something was the launch table, the enormous steel structure that holds the rocket before liftoff. When the explosion happened, this table collapsed straight down into the trench. Watching that crane haul it out was almost surreal. The metal looked bent, twisted, and beaten up. It's now sitting inside the horizontal integration facility, which also lost its doors in the blast. Blue says they're going to inspect the table and make adjustments. Given how banged up it looks, that's probably an understatement. They'll basically need to refurbish the whole thing. But once it's back, this table will get a serious upgrade. It's going to hold new umbilical lines that connect to the bottom of New Glenn's first stage. Without a transporter erector to carry those lines, the launch table becomes the new connection point. It's also going to be plugged into the water deluge system, which sprays huge amounts of water under the engines during liftoff to soak up the sound and shock. 7 BE-4 engines fire at once on New Glenn, so we're talking about a lot of energy to absorb. And here's another twist. Our Space Coast live cameras spotted a transporter erector being unloaded from a barge at the Kennedy Space Center this week. But it wasn't the destroyed one. It was a shorter version that Blue uses to test New Glenn's second stage. That raises the obvious question: where is it going? Because with the new pad design, it doesn't really fit the old setup anymore. Here's where we go into speculation mode. Blue Origin also filed a proposal this week to build 4 Lightning Towers in an area called the Merritt Island Launch Zone. That's near their exploration park facilities. On paper, it's a strange spot for a launch site. The towers wouldn't be tall enough to support a full New Glenn. But what if Blue is quietly planning a test stand for the second stage over there? That would explain why they moved the smaller transporter to Kennedy. It would also let them keep testing second stages without interfering with launches from LC-36. And there's more. Blue also announced a deal with NASA to use the B-test complex at Stennis Space Center. That's the same stand that once tested Saturn V first stages and space shuttle parts, and more recently, the SLS core stage. Blue plans to use it for second stage testing too. They say it's to keep launch operations at LC-36 clean and uninterrupted. So maybe the Merritt Island site is meant for something else entirely. Blue is playing chess here, and we're only seeing part of the board. Still, you have to give them credit. They said they wanted to be launching again before the end of the year. That sounded impossible a few weeks ago. Today it sounds ambitious, but maybe possible. We'll have to wait and see, but they're clearly not sitting still. Now, let's talk about Starship, because this is what everyone came here for. After that dramatic abort last week, when the countdown stopped right at 0, SpaceX finally got Starship Flight 13 off the ground, but first, they had to figure out what went wrong before. SpaceX later explained that 4 of Super Heavy's 33 Raptor engines failed to ignite during that scrubbed attempt. The rules are strict. If more than 2 engines don't start, the launch aborts automatically. That's exactly what happened. When engineers went back and looked at the data, they found something surprising. 6 engines had actually run into problems with their oxidizer turbopumps. The pumps weren't spinning fast enough to reach flight speed, and the most likely cause was moisture. Yes, moisture. Water had gotten trapped inside the pumps during earlier operations. When temperatures dropped, that water froze, and the ice basically locked the pumps in place. So SpaceX swapped out the affected engines and prepped for another try. Thursday came and went with poor visibility, forcing another scrub. They needed clear skies because they were planning to push Starship through a zone of high aerodynamic pressure, and they wanted crystal clear tracking. On Friday, the weather cooperated. Starship finally lifted off, and it was worth the wait. Flight 12. Back in the day was mostly a success, but a few nagging problems needed fixing. The booster's return needed work. The ship had to prove it could relight a Raptor engine in space. Some issues from Flight 12 came back on this mission. Others got solved for good. Let's start with the booster. On Flight 12, SpaceX had tried a new way to flip Super Heavy around after hot staging. They changed the ship's engine startup sequence to help the flip happen more smoothly. It didn't quite work. For Flight 13, they revised the approach and made it more forgiving of small timing differences between engines. This time, the flip worked beautifully. Super Heavy turned around cleanly and lit up all 33 engines for a full boost backburn, something that failed on Flight 12. During that burn, the plan was to gradually shut off engines in stages. First, all 33 would fire, then it would drop to 13 inner engines, then just the 3 center ones. The first part of the boost back went perfectly, but SpaceX later admitted the burn cut off earlier than they wanted. You could actually tell from the tracking cameras. The booster's eventual explosion looked way farther out than expected. Then came the landing burn, and this is where things got messy. Several engines refused to light at the start, others quit during the final descent. In the end, Booster 20 slammed into the Gulf. But here's the silver lining. Because a few engines stayed lit until the very end, the booster hit the water at a much lower speed than Booster 19 did on Flight 12. It tried. It really tried. But that was the end of the road for Booster 20. Now for the good news, and there's a lot of it. Ship 40's part of the flight was basically flawless. Every engine stayed lit during ascent. It hit the exact suborbital trajectory it was aiming for. And for the very first time ever, Starship deployed real, operational Starlink v3 satellites in space. Let's stop and appreciate that for a second. Every previous flight has used simulator payloads, empty shells, test dummies. This time, Starship carried 20 actual Starlink V3 satellites and released them into space. And I know you're enjoying this ride, so let me ask a small favor. If this breakdown is helping you understand what's really happening with Starship, tap that thumbs up. It costs nothing, but it helps this channel grow so we can keep covering every launch, every explosion, and every historic moment together. Now back to those satellites. SpaceX wanted to see how the deployment system worked in the real world. The V3 satellites are much larger and more capable than the ones flying on Falcon 9. Once Starship is fully operational, it should be able to launch up to 60 of these things at once. That's several times more Starlink capacity per flight than we get today. Every single one of the 20 satellites deployed correctly. Later, SpaceX confirmed they made contact with all 20 through both radio signals and Starlink's laser links. That's a huge deal. 6 of those satellites were also carrying lights. The idea was for them to shine on Starship's heat shield so their onboard cameras could snap detailed images before the ship began re-entry. You could actually see the lights blinking from the ship as it rotated in space. Unfortunately, SpaceX hasn't shared those pictures yet. Fingers crossed they release them soon, because those images could tell us a lot about tiles. With satellites deployed, Ship 40 got ready for its in-space engine relight. This wasn't a quick 3-second burn like before. It was a full 14-second burn, much more like something you'd need for real orbital maneuvers. You could see the satellites drifting out of frame as the engine fired and the ship pulled away. The burn worked. Then came re-entry, and this is where Starship keeps surprising people. This was the 7th ship to hit the atmosphere in the correct orientation. It survived the plasma phase, that fiery sheath that surrounds any spacecraft entering Earth's atmosphere. It powered through the point of maximum aerodynamic pressure. It performed the dynamic banking maneuver, which simulates the exact approach it would need for a real catch at Starbase Pad 2. And then it did the flip. It did the landing burn. It touched down softly on the water. Then something amazing happened. The ship tipped over, as expected, but instead of exploding, it just floated. It sat there on the Indian Ocean surface, calmly transmitting telemetry and live video back to mission control. Even SpaceX admitted they didn't expect that. And honestly, it was one of the coolest moments of the flight. Because the ship stayed afloat, we got a much clearer look at the heat shield after re-entry. Drone cameras zoomed in on the tiles, and it was stunning. That kind of visibility is priceless for engineers who need to know exactly how the shield is performing. More of that, please, SpaceX. The ship kept sending data for hours after landing. It probably stayed floating for a very long time. We don't know yet what SpaceX plans to do with it. But their recovery ship, Go Oralis, is out there in the Indian Ocean, and we're watching closely. So what does all this mean for the next flight? Well, Elon Musk hinted at something exciting. Pending data review, he said they might actually bring the next ship back to the Starbase pad for a real catch attempt. Read that again, a ship catch. That would mean Flight 14 could be an orbital mission, not just suborbital. And it's possible now because of what Flight 13 proved. The in-space burn with Raptor 3 worked. If Starship can relight in space, it can circularize in orbit. And if it can circularize in orbit, it can deploy Starlink V3 satellites into their actual working positions. That would turn Starship into a real launcher. The booster, on the other hand, still has some homework. Presumably Booster 21 will fly next, and it might need another ocean splashdown test to help refine the boost backburn and landing sequences. So we could see a ship catch without a booster catch on Flight 14. Either way, we are living in one of the most incredible chapters of spaceflight history. Now let's shift gears to Rocket Lab, because they've been busy too. The U.S. Space Force just handed them a $266 million contract for 12 suborbital missions launching from Kodiak Island in Alaska. The deal includes options for 6 more missions running through the end of 2028. These missions will use Rocket Lab's HASTE vehicle, which is a suborbital variant of the Electron rocket. Defense customers have been using HASTE since 2023 to test hypersonic technology. These flights won't reach orbit, they'll arc up and come right back down. That's exactly what you want when you're testing how hardware survives extreme speeds. This is fresh territory for Rocket Lab. Their 9 previous HASTE missions have all launched from Wallops in Virginia, but their connection to Alaska actually runs deep. More than 10 years ago, they picked the Alaska Aerospace Corporation to handle range safety. Now, Alaska is going to be a launch site of its own for them, and Australia keeps popping up in the conversation too. Rocket Lab's Pioneer spacecraft platform has been carrying Varda space re-entry capsules that have landed at the Cunibah test range in South Australia. 4 have already touched down there since February 2025, with the most recent landing in May. This week, new job postings appeared for Sydney and Melbourne. Naturally, people started wondering if Rocket Lab was expanding into Australia. The Australian Space Agency has been talking about growing its own capabilities, but when we reached out, Rocket Lab said no. They aren't planning to launch from Australia. The job postings are just because Australians can work visa-free. Still, Rocket Lab has a lot going on. They just celebrated their 20-year anniversary in July, and they're closing in on their 100th Electron launch. They also announced back in late June that they're acquiring satellite operator Idiom in an $8 billion deal. That transforms Rocket Lab. It makes them a fully integrated space business that builds satellites, operates its own network, and launches everything itself. And their new rocket, Neutron, is getting closer to its debut flight from Launch Complex 3 at Wallops. Rocket Lab is becoming an important industry name. Let's move on to some Artemis news because NASA is putting the puzzle pieces together for Artemis III. This week, the 4th and final RS-25 engine arrived. It had just finished acceptance testing at Stennis Space Center in Mississippi. Now it joins its 3 siblings at Kennedy Space Center where they'll be prepared. Here's something cool. For the first time ever, engines will be installed on an SLS core in the vertical position. That's a big deal. It makes installation easier and gives technicians much better access to each engine. These 4 engines have serious history. Combined, they've flown on 36 space shuttle missions. That includes flights that helped build the International Space Station and John Glenn's return. L3 Harris took these shuttle veterans and upgraded them with modern electronics and better insulation. They'll also run at a slightly higher thrust. Starting with Artemis V, NASA will switch to brand new engines. The first of those has already been hot-fired. Meanwhile, the twin solid rocket boosters for the SLS rocket have begun stacking inside the vehicle assembly building. 10 motor segments will form the boosters. Technicians finished installing the Orion spacecraft's heat shield in early July. That shield is made of 186 individual blocks of AV coat. Ablative means it's designed to char away and take the heat with it during re-entry. Each block was individually inspected before installation. Why so careful? Because the Artemis I heat shield taught NASA some hard lessons. During that flight, NASA found that the coating had lost more char than expected. The issue was gas building up inside the material during the mission's skip re-entry profile. So NASA refined the blocks for Artemis III. They made them more permeable, letting gases escape naturally. The shield should now char exactly the way engineers designed it to. If you got this far, you're clearly a real space fan, and I appreciate it more than you know. Do me one small thing. Drop a comment with your favorite moment. Was it the flip, the floating ship, or the 20 Starlink satellites finally flying for real? I read every single comment, and it helps this channel. Now back to Spaceflight. Over at July's Open Source Convention in California, a booth showed heat shield sections from Artemis I and Artemis II side by side. Artemis II uses a steeper re-entry trajectory, which shortens the time the shield is exposed to extreme heat. Every major piece of Artemis III is now at Kennedy. The mission is scheduled for next year, when astronauts inside Orion will test rendezvous and docking with demonstrators for the human landing system. That will set the stage for the Artemis IV moon landing, currently planned for 2028. And now let's cross the Atlantic to the United Kingdom. Something historic is about to happen up in the Shetland Islands. The RFA-1 rocket has been fully stacked and is sitting on the launch pad for the first time. It's standing at pad Fredo at the Saxavord spaceport. This isn't just another rocket on another pad. This launch will be the first for Rocket Factory Augsburg. It will be the first for the spaceport itself. And most importantly, it will be the first vertical orbital launch ever from UK soil. Let that sink in. The United Kingdom is about to launch its first ever orbital rocket from its own territory. RFA says the rocket is fully integrated and its fairing is capped. Next up is a first stage hot fire test. The company hasn't confirmed whether an actual payload is on board. If it is, that would be a bold move. Back in May 2024, RFA successfully hot fired the Helix engines on the first stage, but when they tried again in August, disaster struck. A turbopump failed, ripping through the stage and taking a chunk of the launch pad with it. Since then, RFA has been rebuilding for 18 months. They've also been developing Helix 2.0, an upgraded engine that will one day deliver twice the thrust of the current version. When RFA first announced their plans back in late 2022, they intended to launch 7 small satellites as part of Germany's micro-launcher competition. They haven't confirmed if those satellites are still on this flight. The launch is set for no earlier than August 10th, so keep your eyes on Saxavord. Over in Japan, JAXA finally got some good news. After 2 devastating test failures, they successfully test-fired a solid rocket booster for their new Epsilon S. Epsilon S is meant to be a big upgrade to the Epsilon rocket, which last flew in 2022. It shares its first stage with Japan's newer H3 rocket. But the second stage, called E21, has been giving them trouble. They test-fired it in July 2023 and it exploded. They tried again in November 2024. Both times the motor performed better than expected. But that extra performance actually burned through the casing, leading to disaster. So JAXA changed strategy. Instead of pushing forward with the E21, they went back to a proven design called M35, upgraded it, and renamed it M35A. This week's test used the M35A, and it worked. That gives Epsilon S a real path to flight. The first launch is still targeted for no earlier than 2026. JAXA also had another quiet update. Remember the RVX hopper that flew for 40 seconds last week? It was Japan's version of Starhopper. Well, this week JAXA said that was its only flight, ever. They got the data they needed and pulled the plug. That's actually not too surprising. Unlike Starhopper, RVX was never meant to lead to an operational rocket. Its lessons will feed into another experimental reusable rocket called Callisto. JAXA is developing Callisto with the French space agency CNES and Germany's DLR. Still, it's sad to see the hopper retire so quickly after many tests. As space fans, we always want more hops. Now let's zoom around the world for a look at the other launches that flew this week. India kicked things off with something historic. Skyroot Aerospace launched its very first orbital mission with the Vikram 1 rocket. Vikram 1 is a small satellite launcher capable of lifting 350 kilograms into low Earth orbit. It uses 3 solid stages and a liquid 4th stage. On July 18th, the rocket lifted off from India's Satish Dhawan Space Center, marking the country's first ever private orbital launch attempt. It performed exactly as expected. About 10 minutes after liftoff, Skyroot confirmed the mission was a success. Vikram 1 carried 4 payloads. It placed them into a 450-kilometer orbit. That is a massive win for India's private space industry, and for Skyroot in particular. Congratulations to the team. Russia launched a Soyuz from Plesetsk, carrying 16 Rassvet 3 satellites for Russian satellite internet company Bureau 1440. Over in China, Orion Space launched its Gravity 1 rocket from a sea barge stationed in the Yellow Sea. The mission delivered 9 satellites into orbit. Later in the week, Caspase, another Chinese commercial launch company, launched its Kinetica 1 rocket. Then, a Long March 3B lifted off from Xichang. This launch is going in the history books. The rocket was carrying a satellite for China's Tianlian communications relay constellation. It works similarly to NASA's TDRS network by supporting communications for the country's human spaceflight missions. But the payload wasn't the story. About 30 seconds into flight, the rocket was struck by lightning. Yes, lightning. Now, that's exactly what you don't want to happen. It caused the failure of the Atlas Centaur 67 mission back in 1987, and it's a big reason why we usually avoid launching in stormy weather. But somehow, the Long March 3B just kept flying. It shrugged off the lightning strike and delivered its payload without a hiccup. That puts it in some pretty exclusive company. Soyuz 2 got hit by lightning in 2019 and still delivered a GLONASS navigation satellite to orbit. And of course, there's Apollo 12, which got struck twice on ascent. The crew switched to a backup power configuration and saved the mission. So the Long March 3B strike is dramatic and lucky, but let's be honest, we really don't want to see this again, because it could go the other way. SpaceX had a busy week too. 2 Starlink missions lifted off from Vandenberg in California. Over on the East Coast, a Falcon 9 launched the MRV-1 mission. MRV stands for Mission Robotic Vehicle. It's a satellite built by Northrop Grumman subsidiary Space Logistics, designed to attach mission extension pods. This week's launch carried 3 of those 400-kilogram pods. 2 of them will extend the lives of Intelsat satellites. The third will operate for Optus. If MRV gets refueled and resupplied over time, it can attach up to 30 of these life extension pods across its design lifespan. In a rare event, this Falcon 9 flew expendable. Booster B1069 flew its 32nd and final mission. That's a fitting send-off for a workhorse. And of course, SpaceX also tried again with Starship Flight 13, which we already covered in detail. Coming up next week, SpaceX plans more launches. One from Vandenberg, lofting more Starlink satellites. The other will fly from the Cape, carrying a classified mission for the National Reconnaissance Office. Its booster will return to the launch site for landing, so expect sonic booms if you live nearby on July 30th. Over on the ISS, crew are leaving. The Soyuz MS-28 capsule and its crew are set to leave the station on Sunday morning UTC after an 8-month stay. The capsule will touch down in Kazakhstan. China also plans to launch a Long March 7A from Wenchang and a Long March 6A from Taiwan. There are still more missions expected before month end, mostly Electrons from New Zealand, though we haven't yet seen airspace notices for them. If Rocket Lab sneaks another launch in, you'll spot it first. Next Spaceflight is the best way to stay up to date with launches happening around the world, and it's completely free. So what have we learned? A whole lot. Blue Origin is rebuilding smarter, not just faster. Their new pad design could change how we think about launch operations for years. Rocket Lab is expanding into new territory, both figuratively and literally, with contracts in Alaska and ambitions that reach far beyond rockets. Artemis III is coming together in ways that feel more real every week. Real engines, real heat shields, real boosters. The moon is starting to feel close. RFA is about to make the United Kingdom a real spacefaring nation for the first time ever from its own soil. JAXA is finding its footing. India just proved that private companies can reach orbit on their very first try. And China's Long March 3B took a lightning bolt to the face and made it. But above all of that, Starship Flight 13 gave us something extraordinary. A ship that flew flawlessly, 20 real Starlink satellites deployed, a successful engine relight in space, a picture-perfect landing in the ocean, and a ship that just refused to sink. It floated peacefully. It sent back telemetry as the world watched in awe. And then came Elon's teaser. The next flight might be catch-ready. If that happens, it's a new era. We'll be watching the beginning of an era where the biggest rocket ever built lifts off, drops satellites in orbit, and comes home to be caught. It sounds like science fiction, but we've been watching science fiction turn into reality every single week. And this might be the most exciting one yet. Thank you for spending time with me today. If you learned something new or felt the thrill of watching Starship float, then hit that subscribe button. We can keep exploring this journey together. Every launch, every explosion, every triumph. Next week could be the week Starship gets caught, and you're going to want to be here when it happens. Until then, keep looking up. The future is happening faster than we can even measure, and it's happening right above our heads.